Okay, this one's a complicated one, so I'll give you some hints, but I'm not going to solve the whole thing for you. You've got a rigid bar. There's a tension T acting on the right end. There is a force on the left end, so this end here is just leaning against the wall. So the wall is pushing on it to the right with F of x, but the force that's pushing up on it is friction, because it's only friction between the wall and this bar that keeps the bottom end here from sliding down. So friction acts upwards. And then you have the weight of the bar itself, which acts at its center. That's at L over 2. And you have another weight added to it, which is a distance x. And you got to figure out how small can you make x before this bar just slips down and falls. So we're going to basically say it's in rotational equilibrium, and we're going to find the minimum value of x. Okay? So the first thing we'll do is we will look at this, this wall right here. Because friction, the Fy is a friction force, we know that the force of friction, which is Fy, always equals mu times the normal force, which in this case is Fx. So there's a relationship between the force in the y direction, the force in the x direction, and that's given by this. We know mu, it's given to you in the problem, and so that's one equation which relates Fy and Fx. I will call that equation number 1. All right, the second thing we're going to do is we are going to add up the forces in the x direction. Okay, so this was just friction that got us this. If I add up the forces in the x direction, they have to equal 0, because this thing's not moving in the x direction. So that is going to give us an equation. The force acting to the right, which is F of x, minus the only other force acting in the x direction, which is t cosine theta, that has to equal 0. So this equation Fx minus t cosine theta equals 0 is another equation, and I will call that equation number 2. I'm also going to add up the forces in the y direction and set them equal to 0. That's going to give us an equation. In the y direction, the forces going up are Fy and part of the tension, t sine theta. Those are the forces going up. Minus the forces going down. There's 2 W's going down, so that has to equal 0. So the forces in the y direction give us another equation. I will call that equation number 3. Lastly, we're going to look at the pivot here, and we're going to ask what's going on at the pivot. So if I make this end over here the pivot, and I label it P, I can add up the torques about the pivot and say that they must equal 0. That's going to give us an equation. Fx and Fy do not contribute any torque because they are acting at the pivot. So we are going to have T, the tension, times the distance it acts, which is L, the length of the bar, which you know, it's given to you in the problem, times the sine of the angle between them. So that's the sine of theta. That's the positive torque. Minus the weight of the bar, so that's W, times the distance it acts, which is L over 2, minus this weight right here, which is W, times the distance it acts in the pivot, which is X. And so all of those terms add up to 0, and we will call that equation number 4. And really, that's all the physics there is. You've used friction, the sum of the forces in the x and the y direction, and the sum of the torques to give you 4 equations, and you are trying to find x. Okay, so I'm just going to give you some hints here on how to do it. Probably the easiest way to do it is to take equation 1 and substitute it into equation 2. So equation 1 is solved for Fy. I'm sorry, we're going to stick that into equation 3. So take equation 1 and stick it into equation 3. And that will, so you're going to take this equation here, Fy, and stick it in right there for Fy. And then you'll have equation 3 with no Fy in it. It'll just be mu Fx. Okay? The second thing you want to do is take equation 2 And we're going to stick that into equation 3. So equation 2 can be solved for f of x. Stick that into what you have for equation 3 now, and that will eliminate f of x. Then you're going to have equation 3, which isn't going to have any x's, f of x or f of y's in it. And so you want to solve what's left of equation 3 for w. And then lastly, you can substitute this w that you find into equation 4. And when you do that, all the t's will cancel, and you can solve for x, the minimum distance for this last weight. Okay, so that's going to be the general strategy to solve it. I'm not going to help you much more than that. So you can make sure you can get these equations set up, and then solving it is a little bit difficult, but you guys are smart and you can use a challenge. So good luck on that one.